using monopropellant hydrazine for its 8-thruster propulsion system. And the PACE satellite has been on the Space Coast for a few months now. It arrived back in November at the Astrotech Space Operations Facility here in Florida, and it was unboxed, processed, and then attached to the payload adapter and the payload adapter fitting. Last week, it was encapsulated in the payload fairings before being transported to Space Launch Complex 40. The PACE satellite is now poised and ready for launch. Now, let's take a closer look at the mission with some social questions for our ocean expert, Laura Lorenzoni. We appreciate you for sending those in using hashtag AskNASA, and we ask you to continue sending them in during today's broadcast. Our first question comes from someone called HiQ, and they ask, NASA has studied Earth's atmosphere in the past. What is it that you hope to learn that you didn't already know?
That is an excellent question. And one of the things that we're really looking to better understand is that relationship between the atmosphere and the ocean, and in particular aerosols. And so we know that the ocean produces aerosols, and these are also very important for cloud formation. And there are different types of aerosols. And so PACE is going to have two polarimeters looking at our atmosphere. And these aerosols are really critical for climate regulation. And it is one of the biggest uncertainties we have when we look at climate models. And these models are really, really essential for us to be able to understand where we are now and where we're going into the future. So PACE is really going to be able to help us better constrain our climate and understand what we should expect.
Right. Thank you so much for answering that question, Laura. We have another one coming to us from Instagram. Armando_305 on Instagram asks, will these studies help us learn more about red tides?
Excellent question, Armando, and absolutely. So PACE has one of the other, and it's the key instrument that PACE has is the ocean color instrument. And as the name indicates, it looks at the color of the ocean, but it looks at it in a way that is hyperspectral. And every phytoplankton, and these are the small algae that live in the ocean that are the base of the food web, they have different sizes and shapes, and they each absorb light differently. And this is like a fingerprint. And so by knowing what kind of species are there, because this is what PACE is going to enable, we're going to be able to know which is a good phytoplankton, which one is a misbehaving phytoplankton, and this is going to help us then better understand the distribution of harmful algal blooms and also predict where they might occur.
Right. So, I mean, people online really want to know a lot about these tiny particles, these phytoplankton. So, Con Savvy on YouTube also sent us a question. He says, what kind of data does the phytoplankton on the surface give?
So basically, it's light what we're looking at. And so this, again, these very particular light signals, the color is what we're going to be looking for. And we're going to learn more about that as we share this morning with you.
Exactly. Yeah, a lot more to learn about these tiny phytoplankton microorganisms that live in the ocean. So clearly, there is a lot to unpack. There's a lot to know about this PACE mission. We ask that you please continue to send us your questions using hashtag AskNASA. But because there is so much to learn about PACE, Laura and I won't be the only ones that you hear from today. We also have NASA's Megan Cruz standing by at a nearby launch viewing location to introduce you to some of the key people behind this mission. But first, let's check in with our launch commentators, Daryl Nail and Mick Woltman over at Hangar AE.
Thank you very much, Jasmine and Laura, and welcome into Hangar AE. I'm Daryl Nail, joined by Mick Woltman, guy who has 30 years plus of experience in the rocket industry, so we're glad to have your expertise here. Let's talk first about the weather. It was a big deal the past few days. In fact, it canceled a couple of launch attempts for the first two calendar dates that we had. Low pressure system came over the state, lots of wind, too high to go. But in the end, on the third day, well, we had nearly perfect conditions. We are more than 95%.
Yeah, more than 95%. Absolutely. The last couple of days, it's been a 60+% possibility violation due to the weather. But as you said, it is cleared tonight. The weather looks really great. Launch weather officer briefed us just a few minutes ago, and everything is absolutely perfect for a launch early this morning.
And there's a look at the rocket and the spacecraft on Space Launch Complex 40 out there at the Space Launch Complex, 40, a Slick 40 as they like to call it. And you'll see the spacecraft at the top of the rocket. The booster is reused. We'll get a little bit more into that later on, but we are getting ready to flow propellants into the rocket. You can see some of the condensation from the tank farm for the liquid oxygen kind of blowing around there. We don't have any propellants in there yet, but we're about to go. You mentioned the weather. In fact, they dropped the weather brief that they do shortly before going with the propellant. So it's that good out there, folks. Let's talk a little bit about the trajectory. This is the first time in 60 years that we're getting a Cape polar trajectory going out of a mission with NASA.
Yeah, absolutely. We're going to be taking this Cape Polar trajectory, which is unique. We're going to hear about that a little bit later from one of our analysts, but looking forward to this. Normally we would launch out of Vandenberg, but tonight's going to be the Cape.
Let's listen to that poll. Well, we did hear the poll by the NLM given at T-minus 44 minutes, and so that was good to go. We expect that these polls will get a go as weather is green across the board, and we've already checked with the spacecraft team. They're good to go as well.
Yes, absolutely. NASA's launch manager, Tim Dunn, polled the NASA team and the spacecraft team. So we'll about T-minus 35 in about 3 minutes, we'll get ready to start LOX and RP1 loading.
SpaceX has a number of polls that they do as well. All of this counting down to propellant load, which happens at T minus 35 minutes and counting.
Yeah, correct, Daryl. As we get ready to go, the team is definitely looking at everything, making sure there's checking things through the procedure, making sure the vehicle is ready, and these polls that we have through the evening or early this morning verify that all the systems are ready. And as we said, we heard that poll from NASA earlier, and SpaceX will continue moving forward, getting ready for propellant load.
This is a unique trajectory. As we mentioned, Pace is flying today. The first time in over 60 years, NASA is flying a polar orbit from the Space Coast of Florida. I'm joined by flight design analyst Jimmy Smith with Launch Services Program. You did the flight trajectory for the PACE mission. Tell me, it's kind of unique. We're launching initially east, but then heading south. Why is that?
Yeah, so PACE is going to a sun-synchronous orbit, which means it's going to be a near-polar orbit at about 98.1 degree inclination. So we have to launch east and then dogleg to the right to make it to our inclination target.
Now, we get into this orbit pretty fast, only 12 minutes, and you're separating off the rocket.
Yes, we are direct inject to the target orbit, which means we just have one long burn, about a 7-minute burn of the upper stage to get us to the desired orbit.
And it's a steep climb on the way out.
Yes, so by the time the upper stage of the vehicle gets to around the West Palm area, we're already at 180 miles up. And then by the time it crosses over the Homestead to Cuba area, it's already beyond the altitude of the International Space Station.
Most launch viewers know as the rocket takes off east, you kind of lose sight of it as it disappears on the horizon. But this is going south. Will people launch
over to start heading south, and then also the return to launch site of the booster. People as far south as West Palm should get a pretty good view.
Yeah, if you haven't seen a booster come back, it's always
pretty spectacular,
pretty cool show. Jimmy Smith, thank you very much for explaining that for us.
Thank you.
Back out to the pad there, the Falcon 9 rocket, standing ready for propellant load in just about 30 seconds from now.
Yeah, while you were talking to Jimmy, we heard SpaceX Launch Director Charlie Meyer give instructions to the team getting ready for propellant load, Daryl. And as he gave those instructions, everybody looked like they were ready to go. So we'll start RP1 and LOX load here in about 10 seconds.
Launch auto sequence has started.
And there is the call. They're now flowing RP1, which is a refined type of kerosene, rocket fuel, into the first stage of the Falcon 9 rocket. So it begins. We'll be tracking the propellant load as we go. Let's take a quick look at the weather graphic for the conditions right now. I want to show you that before we peel out of here. You can see the winds 15 to 20 miles per hour out of the north. Temperature, a cool 59 degrees. And our percent go, greater than 95%. The only concern is a possible cumulus cloud that could come over top, but it doesn't look like that's in the offing today. A fantastic forecast for launch. And with that, we'll send it back to Jasmine and Laura in the studio.
Thank you, Daryl and Mick. Wow, more than 95% go. That is great to see. So as we just heard those call outs for loading liquid oxygen, we'll pause throughout today's broadcast for those operational updates so you can follow along with the action. Now let's check back in with NASA's Megan Cruz, who's standing by with the PACE project scientist. Megan?
Space Center. With me right now is Jeremy Wardell. He is, as Jasmine said, the PACE project scientist. Good morning to you.
Good morning to you.
How are you feeling being here?
Exhausted and exhilarated. Do you know what time it is?
I do know what time it is, yes. We are very close to launch. That's why we're here. Talk to me about how important are our oceans, which are beautifully depicted on your shirt, actually.
Thank you for appreciating that. Oceans are incredibly important. They produce much of the food that we eat and the ocean that we breathe, but they also regulate climate and weather. They provide compounds used in medicines. They provide for our economy through jobs and recreation. And we know they're changing with Earth's warming climate. But there's so much left we have to discover and to study, and there are things that are happening on daily scales that affect our everyday lives to generational scales that affect the quality of the lives of our children.
Right. So then what will PACE reveal to us about the oceans that we don't already know?
Its reason for being primarily is the study of this amazing microscopic, mostly invisible living ocean. Target are phytoplankton. They operate just like land plants, but they're these beautiful teeny tiny algae. Convert carbon dioxide into cellular material that provides the base of the food chain. Sometimes that carbon gets sequestered or stored in the ocean for millennia. Reason we really care about them is we know that they're changing, and there are beneficial ones that feed fisheries, there are harmful ones that close beaches, contaminate drinking water. But the ocean is big, right? So we need the vantage point of space to study them.
Perfect.
So today we are really great at saying, I see phytoplankton. In an hour, we'll have tools in the toolbox to tell you what communities are there.
I love that. And we're not only focusing on the ocean, PACE is also looking at the Earth's atmosphere.
Exactly. The ocean and the atmosphere are super interconnected, and you can't understand one without understanding the other. So PACE will provide these beautiful direct measurements of clouds and atmospheric aerosols, which are anything that range from pollen to sea spray to volcanic ash. You care about this because they inform on air quality, on short scales, and on long scales, you want to understand how clouds and these teeny tiny aerosols are warming and cooling our atmosphere.
Yeah, I love that we're going so far up the vantage point of space, like you said, to see this teensy bit of things that really help us understand our Earth.
That's right. You heard me right. From 400 miles above Earth, we're going to see the microscopic ocean and atmosphere.
Great. Jeremy, thank you so much. I do know that you're tired, but I think it'll be worth the wait to stay up and see the launch today.
It was worth it so everybody could see the shirt.
Awesome. Thank you so much. I really appreciate you being here.
Appreciate it too.
Back to you, Jasmine.
Thank you so much, Jeremy and Megan. So as you just heard, once PACE is in orbit above the Earth, it will help us observe plankton, which are tiny organisms that live in the ocean. So let's take a closer look at how these small life forms are having a big impact on the planet.
Plankton generally doesn't really mean like a taxonomic group of things. Like, you know, we think about mammals and then plants, and plankton are not that. Plankton are really defined by the way they live. Plankton means the wanderer in Greek, and these are just oceanic organisms that really just don't swim that fast that they can fight the ocean currents. It's a really non-traditional way of thinking about biology in a sense. Plankton we can define traditionally in zooplankton, so something that is kind of more animal-like, and phytoplankton, something that is more plant-like. All phytoplankton does is what we call photosynthesis. They take carbon dioxide and carbon in organic form, capture some of the sunlight, and then produce carbohydrates, or just simply said sugars. They now are carrying that sun energy and push it into the food system of the ocean. And while they're doing all that stuff, they also produce the oxygen. So opposite from us, we inhale oxygen, exhale carbon dioxide. So that's why they're really important. That's why we love them so much, and that's why they're like really crucial for the whole life on the Earth. Phytoplankton itself, its diversity is gigantic. I think there's like 10,000 species, and each of them has a specific role. Why is there so much diversity in something that is so teeny tiny? It's fantasy, science fiction, and horror comes together. I mean, it's just so beautiful. So the changes of the color of the ocean due to the presence of this phytoplankton are just so miniature, no? We cannot see it with our eyes, but if we have sensitive instruments such as ocean color instrument on PACE, we're going to be able to differentiate, not only because it's sensitive to the intensity, but it's also sensitive to the colors. Having this hyperspectral view with really high sensitivity is going to allow me to differentiate much, much more of the phytoplankton, because each of them, or at least each group, has its own optical patterns. It's an optical fingerprint. We're hoping that PACE, due to its capabilities, is going to be able to really focus on specific species of interest, such as the harmful algal bloom species, or species that are very beneficial for the growth of certain organisms. So this speciation is a function of the technical abilities that PACE has, but it's a function of our capabilities to understand the local ecosystem.
joining us now live in person to talk more about phytoplankton is NASA oceanographer Ivana Sejtanic. Thank you for being here.
Thank you for having me.
Of course, we're really excited to have you. So, as you know, the space coast of Florida sits on the Atlantic Ocean. So you took a field trip down to the water to get a phytoplankton sample. Can you walk us through what you did?
Definitely. So together with my colleague Bridget Seegers, we went on just really close by here on the dock on Kennedy site, and we deployed a plankton net. And plankton net is something that we use in oceanography to actually see what is in the ocean, like, see with a microscope. So imagine this plankton net being something of a butterfly net for plankton, but the pore size, these holes in that net are so teeny tiny that your hair cannot pass through it. And therefore, that allows us to capture everything that is in the water, phytoplankton, zooplankton, all these planktons, and sometimes some other things that just fall from the atmosphere. So we have collected a lot that day because this area is really, really, thick with phytoplankton. So yeah, that's just something that we do to kind of like see what is in the ocean, and sometimes we look it from the sky.
Right, awesome. So you went and collected this sample of phytoplankton here for us.
Yes.
Okay, awesome.
Here it is.
This can't be seen, of course, with the naked eye. So you also have a microscope, and you are going to teach Laura and I how to observe phytoplankton, right?
Yes. So once we collect the sample, we're going to use these like really traditional tools to observe them. I'm just going to take a little droplet of this water that we have collected and show you the beauty in this droplet of water.
Awesome.
Pretty simple. You go there, you pick up some water, you put it in a microscope slide, put this inside. We don't need this anymore. And I'm going to slide it under, and we're going to see what we're going to see. I don't know, some magic maybe, some party people.
Yeah, okay. Oh, wow, okay, very nice.
Okay, oh wow, yeah, it's up there. Okay, so what you're seeing here in the middle of this line, it's called a diatom. There's actually 4 or 5 different little cells together, and the little dots inside are these chloroplasts that they have, which is the green color that allows us to see it from space. Usually I would expect some runners running around here, which are little flagellates, which are sometimes animals, sometimes plant. They can do both things. But these guys in the center are really fascinating because these are the type of phytoplankton that lives in a glass shell, and they're really, really good for carbon export.
Right.
So, yeah, really fascinating.
Yeah, that really is fascinating. Our audience out there, they have a great view on screen. We have a beautiful view right behind you too, Ivana. So as we're kind of looking in this jar, we see, this kind of dirt or something at the bottom there. It actually has color, right? So where does that color for the phytoplankton come from, Laura?
It's within the different phytoplankton species, and so each phytoplankton has a different size, different shape, and different pigments, and so that is what sets them aside from one another, and that's just like a fingerprint. And this is where PACE is so critical, because being able to see the entire spectrum from the UV to the near infrared at such a fine resolution, it's going to be able to help us pick out what kind of species are in different types of water, what is the community composition, which is really critical for a number of functions that our ocean performs for us.
Right, so before in the past we could kind of see that there was something there, now we can identify what is really in the water. So what does ocean color really tell us about ocean health, Ivana?
That's a great question. Oh, by the way, there's like one little swimmer.
Oh, yeah, wow, look at him, he's swimming around.
So again, ocean color is highly dependent on phytoplankton that lives in there, and phytoplankton is based on marine food web, so it's really directly connected to everything that we care about in the ocean, even like charismatic megafauna, but fisheries that we depend on. But the biggest, in my perspective, service that ocean does and phytoplankton does is this carbon control of the carbon flux in the ocean. These little guys that I'm showing here, these diatoms, are really, really crucial because they're very good in taking this carbon from the surface and taking it down deep into the ocean, removing it from the contact with the atmosphere, and therefore allowing this carbon to flow and, in a sense, controlling our climate.
Right, we're really kind of seeing the Earth ecosystem come together for the first time with PACE.
Exactly.
Awesome. Thank you so much, Ivana, for that explainer. We really appreciate it. Now let's check back in with Megan Cruz, who's standing by with one of our key scientists from Goddard. Megan?
Yeah, welcome back here to OSB2, which is a viewing location here at Kennedy Space Center. And I'm with Krista Peters-Ledard. She's the Director of Sciences and Exploration at NASA's Goddard Space Flight Center. Great to have you here. What a great night for a launch.
Yes, thank you. We're all excited.
So talk to us about how PACE fits into NASA's broader goal of Earth science research.
Yeah, so PACE is going to be part of our amazing Earth science fleet, and it is going to revolutionize our understanding of the ocean. So we are going to use our recently launched satellite, the Surface Water and Ocean Topography Mission, SWOT, which tells us about the height of the ocean, and then PACE will tell us about the biology of the ocean. So combining the two together will give us an unprecedented understanding of how our oceans work. And that's really important for understanding climate change and how the Earth as a system will respond through the carbon cycle as well as the water cycle to changes.
Yeah, really great science that's being done on this mission. But then how do people, everyday people, how are they affected by what we learned through PACE?
Yeah, so PACE really will impact three key applications areas. So the first is fisheries, the second is water quality, and the third is air quality. Fisheries are so important because we eat fish and we enjoy it, and the base of the food chain comes from the phytoplankton and algae that PACE will help us to understand. In addition, though, there are harmful algae that can affect the water quality. We're in Florida where beachgoers might not be able to go to a beach because it's closed. And so understanding those types of not so good algae will help us, impact our ability to predict that. And then finally, air quality, right? So when wildfires happen, the dust and the smoke transports downwind. And so the aerosol measurements from PACE will help us to know where it is, how much is there, and then how much might impact downstream people.
Krista, really quick, what's next after PACE? PACE really sets us up for some really great science in the future.
Oh, yes. So the technology and science from PACE will feed into our next initiative, which is the Earth System Observatory. And being able to use those technologies from aerosol and clouds, understanding our Earth as a system, will help us to predict the future and how climate and the Earth system will react. So it's great.
Krista, thank you so much. I can feel your excitement. I really appreciate you being here.
Yeah, thank you so much, and go PACE.
Jasmine, back to you.
Thank you so much, Megan. So now Laura and I have some pictures to show you, one with only 8 crayons to demonstrate our current view of ocean color with satellites, but one with 128 crayons to show you where we are going to go with PACE and its instruments. So let's talk about this, Laura. How are we going from this to this?
We've come a long way, Jasmine, and our heritage ocean color started back in 1978 with the Coastal Zone Color Scanner, a totally revolutionary instrument that allowed us to actually see how dynamic our ocean is. And the Coastal Zone Color Scanner was what we call a multispectral instrument. So basically, it only have a few colors that you could see what was in the water. So it didn't really help us differentiate all the wonderful species of phytoplankton that we've talked about and what is contained in the water. And while our technology has advanced and we've been adding bands to our multispectral instruments, we haven't had anything like PACE, which is truly hyperspectral and allows us to see the true color of our ocean. And PACE is not just wonderful because of this, but it also continues that long heritage of over 25 years of uninterrupted measurements that we've had, which is critical to really unravel the trends in climate and ocean change that we have.
Right, and there's a lot of data going on here. We also are hearing the callouts as well. We just heard that stage 2 RP1 load was complete, but there is a lot to unpack here with the PACE mission. So, we're going from these 8 crayons, 128 crayons, but really what's important is that the ocean connects us all. So it's only fitting that the PACE team has members from around the globe. Some of the children of those PACE team members sent in well wishes for today's launch. Let's take a look.
Mucha suerte, PACE. ¡Hija, PACE! ¡Yay!
Mucha suerte a todos los del proyecto PACE.
Buon viaggio, PACE! Boas PACE!
Setan pour PACE.
Boa sorte, PACE! 데레데레 수박가마나 PACE! 우주를 향해 날아라 PACE!
Mavafakroshi PACE.
Bonne chance, PACE! Benairin Cola PACE. Good luck, PACE! Good luck, PACE! Lycka till, PACE!
Groeten van Zuid-Afrika NASA. Ons wens jullie die beste toe vir die PACE-program.
Awash wa Payota PACE! Super PACE!
PACE.
Buena suerte, PACE! Estamos muy emocionados por PACE! Бажаю удачи, NASA PACE! Hurrah!
Good luck, PACE.
Come back there! We're so excited for you, PACE!
It'll be awesome to see the ocean in so many different colors.
Good luck, PACE! Good luck, PACE! Good luck, PACE!
Kali Pitihia Pace.
Salamat Maju Jaya Pace. Estamos muy emocionados por Pace.
That video was just precious. It really warms our hearts here. And I know that that was a project very near and dear to your heart, especially, Laura, right?
It was, and we received over 40 entries from 32 countries. And the one thing that I heard every parent tell me when they were doing this is how much fun they had with their kids putting these videos together. And that means a lot to us because oftentimes our work at NASA is very time consuming. It can be a lot, and we wouldn't be able to do this if it wasn't because we had the support of our families. And the work that we do, so for example, the PACE mission really is done so that we can have a better planet for our children and their children. So this really meant a lot to all of us on the PACE project.
It really did. And Laura, thank you so much for just having all those parents send those in. It was really sweet. I know that you're here, your son is here watching launch as well, somewhere nearby. And so this really is a family affair.
It is. And you can watch the entire video with all the entries on the PACE website.
Awesome. That is so nice to see. Thank you so much for that, Laura. So obviously, keeping the planet healthy is important for the next generation. And thanks to NASA's Office of STEM Engagement, we now have a new way to teach them about Earth and climate science. It's called Earthrise, a monthly newsletter that provides K through 12 educators and learners with a focused collection of Earth science resources. You can scan the QR code on your screen now to register and learn more. All right, we are now about 16 minutes and counting from launch, so let's get a closer look at PACE and those 3 science instruments it will use to uncover a sea of data.
Where we are today, think of as the box of 8 crayons, and you can do a lot of amazing things with that. So the information content for any singular instrument on PACE is way more than we're used to. OCI is going to be the box of 96 or 128 crayons, and so suddenly the tools you have at your fingertips will fill in all the gaps of color that we could possibly want. This observatory is going to provide global coverage every day. That is another scale of this total volume that is really, really increasing the amount of information we're going to have to work with. We know the atmosphere is changing. We know carbon dioxide levels have increased. We know that it has warmed our atmosphere. Circulation patterns are changing. Places are warmer than they used to be. The deeper dive we take into the relationships between land, ocean, and atmosphere, the more we realize we don't know and we need to learn.
NASA is preparing to take that deeper dive with the Plankton, Aerosol, Cloud, Ocean Ecosystem Mission, or PACE. The exchange of carbon between the oceans, land, and atmosphere. The impacts of atmospheric particles on marine communities of phytoplankton. The changes these communities are experiencing in a warmer Earth. Reducing the uncertainty of aerosols in scientific climate models. PACE will improve our understanding of these complex connections and how these systems are affected in a changing climate. The color of the oceans can tell us a lot about our changing Earth systems. And so PACE carries the Ocean Color Instrument, or OCI, to continuously measure the interaction of sunlight with substances in seawater, such as the green photosynthetic pigment chlorophyll A.
We're very good today at saying there's a lot of green, meaning there are a lot of plants. Where we want to go with OCI is what kind of plant is actually there. And so by looking at more color, you can actually start getting the subtleties of this green versus this slightly different shade of green, and then relate that to the composition of what you're looking at.
PACE's other 2 instruments are multi-angle polarimeters, one hyperspectral and the other hyperangular. Together, they'll take on aerosols, tiny airborne particles, and clouds, both of which change how sunlight interacts with the atmosphere. The data from PACE will help scientists reveal complex relationships that connect the atmosphere, ocean, and land in ways that help explain changes we see in our own lives, and in ways that impact generations to come.
The data from PACE could be used to inform industry and policymakers. To learn more about that, let's bring back NASA's Megan Cruz, who's standing by with one of NASA's lead scientists. Megan?
So I'm here now with Nikki Fox. She's the Associate Administrator for NASA's Science Mission Directorate. She's very cold. She just came from upstairs, and it's pretty windy out there, huh?
It is pretty cold still, yes.
The weather is still good for launch, so that's really good. Tell me how PACE is another important asset for NASA.
So PACE is just, yet another jewel in the Earth science fleet. So we have 20 Earth science missions that are working together to study all different elements of climate, and PACE is joining that amazing fleet with this kind of unique capability of looking not just at the health of our oceans and all of that, but also at the health of the air that we breathe.
Yeah, how is it that these small little things in the ocean, in the atmosphere, the phytoplankton, and also the aerosols, how are those key for us to understand climate change?
So actually, because phytoplankton are just these amazing little beasties. They're about half the size of a human hair.
Wow.
They're tiny, and yet they actually they take about 50%, actually they produce about 50% of our oxygen. They take carbon dioxide out of the air. They, like a plant, carbon dioxide, sunlight, some nutrients, they grow. They actually take the carbon dioxide and they produce oxygen. So, and they also are the bottom of the food chain, so they're like a little superfood in the ocean as well. All different types of phytoplankton, all shapes, all sizes, all playing their part in ocean health.
And then aerosols, why is that so key in the science that we're doing right now?
Actually, because aerosols is one of the least kind of understood in the climate puzzle. And so with PACE, we're looking not just at the ocean, but also at the air that we breathe. If you think about the wildfires that we had in Canada, and it came all over the U.S., down to Washington, even further, all through the Midwest. Smoke and pollution don't follow boundaries. They don't follow borders. We all breathe the same air. And so it's really about understanding each of the elements of climate all together. And go PACE. Isn't it wonderful?
It is wonderful. And what's wonderful, too, is that data from PACE will be shared with the public.
Yep, that's actually one of my favorite parts, actually, about Earth science, to be honest, because every single piece of data that they take is so important. And it is about getting this critical data and this sort of cutting edge science with these first of a kind observations that we make with our NASA spacecraft, getting it into the hands of people that need it, people that make decisions, our stakeholders that look after us as a community, make sure the drinking water is safe, make sure that the air we breathe is safe, and then also to our friends that our farmers, our fishers, everybody that really needs this critical data. And so getting it out, making it usable, accessible, making it easy to understand, and also getting it into our Earth Information Center, which you can see at earth.gov.
Wow. To sum up everything you said, I mean, go PACE.
Go Falcon, go PACE. Go PACE, please go PACE.
Thank you so much, Nikki. I'm so glad that you can come down here and warm up with us for a little bit, and now we're going to go back outside and see a launch.
That sounds great.
Great. Back to you, Jasmine.
Thank you so much, Megan and Nikki. NASA's Artemis missions to the moon could help inform our understanding of Earth's oceans. To learn how, here's your Artemis Moon Minute. Observing and monitoring the world's ocean from space requires very accurate measurements. And in the harshness of space, measurements from instruments in orbit can drift in accuracy, impacting the quality of satellite observations of Earth. So, we turn to the moon for help. During NASA's Apollo era, scientists at the U.S. Geological Survey used lunar samples to develop the concept of lunar calibration, which uses the moon as a benchmark for fine-tuning the accuracy of satellites observing Earth. And NASA's Artemis missions could provide new data to further improve the accuracy of lunar calibration for satellites. NASA's PACE mission will take regular measurements of the moon to make sure its instruments continue to provide accurate data needed to understand how the Earth's atmosphere and ocean are changing. That's a look at your Artemis Moon Minute. So Laura, let's talk about that lunar calibration we just mentioned. How often will PACE take those measurements of the moon?
PACE is going to be looking at the moon twice every month, and it's important to realize that we've been using lunar calibration for a long time. CUIFs, MODIS, and VIIRS, all of these top-of-the-art sensors that we've used to look at the ocean so far, all have looked at the moon, and the moon is really important to make sure that we continue to have that high-quality data that is coming from our sensors.
Now, that's really neat to see that, we're actually using the moon to get a better view of Earth. So thank you so much for that, Laura. All right, so now we are only about 8 minutes and counting from liftoff. So let's take a look back at Daryl and Mick to walk us through the final moments of the countdown and liftoff. Take it away.
All right. Thank you very much, Jasmine and Laura. And we are back in Hangar EAE, where we've been monitoring the propellant tanks getting filled. We got 1 out of 4 down, 3 to go, and that's the 1 RP1 tank on the
Stage 2.
On the Stage 2. Mm-hmm. And then, of course, we've got the LOX, both Stage 1 and Stage 2, still filling up right now.
Yeah, Stage 1, RP1 is almost complete. Team is continuing to fill the commodities in there and get ready for engine chill and preparations for launch this morning. But so far, things are going really well.
And there you see the Falcon 9 out at the pad, Slick 40, as the propellants are flowing in. That's super chilled liquid oxygen condensing the warm Florida air, which is not as warm as it's normally been at 59 degrees, but it's still humid, so you're going to see it condensing the air. And Mick, this booster, though, this is a pretty young booster overall for SpaceX. Only 3 previous flights. We have a graphic to illustrate the launches that this rocket has accomplished. And there you see it all began with Crew 7 back in August of 2023, followed by another trip to the International Space Station with CRS-29, and then finally Starlink 634. So it had a human spaceflight mission. It went to the International Space Station. It also did a Starlink, and here is number 4 with Pace.
Yeah, Daryl, we're very excited to be the 4th flight on this booster. Launch Services Program actually supported our commercial crew program, our sister program, on that Crew 7 mission. We looked at this booster and did some hardware reviews for them, and so we've got
started.
So we know a lot of history about this booster, and as things move forward. There we just heard the call out for engine chill starting for getting things ready for launch this morning, as we have the RP1 and LOX filling up the tanks.
Yeah, those tanks are mostly full as we're looking at the rocket here from a distance, getting ready to complete that. In fact, we should hear a call out in just about 30 seconds that the Stage 1 RP load is complete. And then we'll start moving through a number of milestones where we get that rocket ready to be on its own.
Yeah, absolutely. The team will finish that up, and then they'll start their sequencing to get ready for the flight computer.
Stage 1 RP1 load is complete.
And there we heard the call out for Stage 1 RP1 load complete. And as I was saying, the flight computer then will take over as sequencing the vehicle to get ready for launch as it sends on its way on that 98-degree inclination that you and Jimmy talked about.
It's a steep inclination. It's going to get up into space in a hurry. A Cape Polar Orbit, which hasn't happened for NASA from this location in 60 years. It's an exciting time to see a rocket flying to the south, going over Florida and Cuba.
Yes, heading south and then making a dog leg to get into that polar orbit. Normally we would do these from Vandenberg Air Force Base out in California. But due to the performance and things that we have on here on the Eastern Range with this Falcon 9, we can do this Cape Polar Orbit out of here. And so very excited to see that happen after 60 years.
A number of milestones coming up here shortly in just a few seconds. We're going to retract the strong back that's holding the rocket in place that you see out there on the pad. And we're also going to get the spacecraft on internal power. Test Director Nusha Hagani and her team getting ready.
Falcon 9 tanks are pressurizing for strong back retract.
So there we heard strong back retract, as you mentioned, Daryl, and also heard from the launch manager and the SMD for the spacecraft that they are on internal power and configured for launch. So things are moving along here very quickly as we get ready to get down to T0.
Strong back retract has started.
And lift off pace this morning.
And now the strong back will retract just about 2 degrees prior to launch. It'll go further once the rocket lifts off, clearing the way to allow the rocket to go. And we're awaiting checkout from
LD,
the NLM.
this is NLM on countdown net. LD, pace is go for launch. Copy.
All right, NLM Tim Dunn giving the go for launch for the NASA team, the spacecraft team, and launch services program. SpaceX now proceeding forward.
Yeah, things are progressing. That's good to hear that the spacecraft's on internal power and everybody's ready to go. We should be coming up on LOX load complete here in about 15 seconds for stage 1 and about another minute for stage 2. But as we're looking at the data here in front of us, Daryl, here in Hangar AE, things are progressing very well, and the team is performing admirably this morning, getting this vehicle ready for liftoff at 1:33:36.
The final
Stage
fill.
1 LOX load is complete.
There you go.
So stage 1 ready. We're just waiting to finalize LOX load on stage 2 and continue moving forward, and then we will get into some of that flight sequencing and getting the autonomous flight termination system ready to go, and then the final go at 45 seconds from SpaceX before they turn the vehicle over to the flight computer.
And once they get down to 45 seconds, there's no more holding the launch on the count of the spacecraft. They'll be committed at that point.
Yes, absolutely. Having all this cold LOX in on the first stage and second stage commits us to this time, and things are looking good.
There was a slight adjustment to the T0, Mick. It was 1:33 and 32 seconds, but it slipped 4 seconds due to a COLA real quickly. Why is that?
Stage 2 LOX load is complete.
There we hear stage 2 complete, so that's a good sign. But the COLA is our collision avoidance analysis that we need to do to make sure we don't hit something that's in space already as we lift off and ascend this morning. And the original time, as you said, was 1:33:32, and we had 4 COLA conjunctions this morning for those seconds, so we went to the next
ground gas closeouts.
Next second that we could, and that put us at that 1:33:36. So things were able to adjust very quickly for the 4 seconds and get ready for launch this morning.
And you see the large plume, the large cloud coming around the Falcon 9 rocket, and that's the venting off of the liquid oxygen in the line that runs up to the second stage. Proceeding now, T-minus 1 minute and counting until liftoff of Pace and the Falcon 9 rocket.
Falcon 9 is in startup.
So there we hear Falcon 9 is startup, configuring all the systems. Autonomous FTS is being configured. The systems are being
SpaceX launch director, go for launch.
And there's the big moment. T-minus 40 seconds and counting. Many on the Pace spacecraft team now going outside to watch this launch. It should be a beauty.
T-minus 30 seconds.
All systems are go. Getting down to the final seconds.
15 seconds. T-minus 10.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Booster ignition. Full power engines and liftoff of the Falcon 9 and Pace, helping keep pace with our ever-changing ocean and atmosphere.
Stage 1 propulsion is nominal.
All 9 Merlin engines lit up and roaring. 1.7 billion pounds of thrust.
pressures on the telemetry are feeling good here. Daryl, 9 engines performing very well.
That's great news.
Power and telemetry nominal.
Makes its steep climb into its orbit. Ride about 2 minutes on the first stage. A view from the rocket camera.
Vehicle supersonic.
There we hear Falcon 9 supersonic coming up on max Q, maximum dynamic pressure on the launch vehicle.
Max Q.
pass through max Q. The vehicle continues to perform nominally, all 9 engines firing.
MVAC engine chill has started.
Starting to chill the second stage engine to get that ready. They bleed a little bit of LOX in there so it doesn't get thermal shock once they light it up. A view there, looking down the first stage booster. Getting ready to cut off the engine and separate. We'll have a number of milestones all happening quickly in rapid succession.
We're about 10 seconds from main engine cutoff, and then we'll have stage 1, 2 SEP, and then stage 2 ignition.
Nico. Stage separation confirmed.
And there it goes, the first stage of the rocket. Second stage now lighting
MVAC
up.
ignition.
Stage 1 boost back startup.
You see the glow of the first stage as it falls away.
Excited to see that first stage come back here to landing zone 1 this morning. That will be great as stage 2 continues to perform. Getting that stage back here will be exciting.
If you're here on the Space Coast and you're watching, get ready for a double thunderclap at just about T+7 minutes, 7 to 8 minutes. The double sonic booms of the first stage booster breaking the sound barrier as it returns to Earth.
Stage 1 boost back shutdown.
So now the first stage has positioned itself on a return trajectory back here to landing zone 1, which is only a mile or so from our location at Hangar AE. We get quite the thunderclap.
I always love to hear the landing zone back here when we're in the hangar. We're about 10 seconds away from jettison fairing of the payload fairing, exposing PACE to the atmosphere.
This is a big moment for the spacecraft team.
Fairing separation confirmed.
Looking inside, there go the fairings, revealing the PACE spacecraft to the elements. Now PACE will seek to get a signal on the TDRS satellite for our first acquisition of signal.
Yeah, this will be a downlink of a low-level signal on the TDRS network, utilizing the telemetry network to verify that PACE is the transmitter is on, and then they will continue monitoring the spacecraft until separation, and then be able to get their data once they get power positive that we'll see later.
And in that moment you just described, that time period that you just described, they'll only be monitoring data coming from the PACE satellite. They will not be sending any commands in.
Absolutely. Nothing until the spacecraft separates from the stage 2. The spacecraft team will just continue to monitor the health of the spacecraft using the TDRS network and looking at the telemetry. Everything so far on second stage is performing very well. Looks good on our trajectory. They just made a call. Somebody called ASO, but nobody's answered.
And there's a shot from the first stage booster as we're coming back down to the Cape. You can see the lights of the Space Coast. It's a pretty shot.
I love that shot. Seeing the coast of Florida come back into view.
2 more burns left.
Stage 1 entry burn startup.
That's the first one, the entry burn, for about 30 seconds. You see it lighting up now. Grid fins are out to help give it a precision landing, guiding the first stage booster back to landing zone 1. split screen now. Well, we did have it. There's a
Stage
shot.
2 FTS is saved.
There's a shot of the booster coming back down from the ground.
Stage 1 entry burn shut down.
Stage 1 FTS is saved.
All right, and in comes the first stage booster. Second stage continuing on a nominal trajectory. You can probably see us in there somewhere.
I love that view at night too. To see it'll be really nice to see that as it gets closer. The coast of Florida as we come up on landing zone 1. Stage 2 continues to perform nominally
Stage
on a
1 transonic.
great trajectory for stage 2 as spacecraft continues to look very well during this flight.
Stage 1 landing burn.
All right, there goes the landing burn. In just a few seconds, we'll have a booster on the ground. A look from the ground. We hear the thunder here at
we
Hangar
hear those
AE.
double claps.
Landing leg deploy.
Here she comes.
Stage 1 landing confirmed.
Another pinpoint landing by the first stage booster. Flight number 4 for the first stage in the books. Second stage continuing to burn on a 7.5 minute direct inject into orbit. This will be a quick ride, Mick.
Very quick as the continues to perform very well. We're looking for this to continue firing, and we'll get second stage cut off at around T plus 10 minutes, but things look very well on the telemetry. Vehicle's performing very well, and MVAC is nominal.
The second stage on a Cape polar trajectory hasn't been done by NASA in the past 60 years. SpaceX, though, has done it 11 times. This would be the 12th. Actually, check that, just about a minute left on the stage 2 burn. There will only be one stage 2 burn.
Yeah, as Jimmy explained to us in the trajectory, this is a direct inject sun synchronous orbit. So just a single burn for the stage 2 this morning. And things continue to look well. Chamber pressure on MVAC and trajectory look nominal.
And then we'll coast for just a few minutes and separate the Pace Observatory. Standing by for stage 2 cutoff, known as SECO 1. We'll have that in just a few seconds.
MVAC shut down.
All right, there you have it. And we're going to coast for a few minutes and take a look at the forward-facing camera so we can see the Pace spacecraft, which is being monitored by the spacecraft team. The engine nozzle on stage 2 still glowing just a bit from a 7.5 minute burn.
Yeah, all telemetry on stage 2 looks nominal for the flight. Looks like a very good stage 2 performance so far. So we'll see how things go as we get ready for spacecraft separation.
Now just about 1 minute away. This is a big moment for the PACE spacecraft team, one in which they're holding their breath a bit. There you see PACE now.
I love that camera view from the front of the stage 2, looking at the PACE spacecraft out there in that dark space right now. Things are looking really well, and I love that. Love to see that camera view.
Dark indeed, as they launched into an orbital eclipse. So PACE has no sunlight on it, as you can see. But the hope is once they get those solar arrays deployed, a critical moment, they're going to be looking to get power on it. There goes PACE.
Payload separation confirmed.
Off into space on its own, flying free. We've got applause here at the Mission Directors Center at Hangar AE. Looks like a good separation. Vehicle pretty stable.
Yeah, launch vehicle performed very well today, and glad to see PACE separated. We've got a few more milestones that the team will be working on to get PACE to power positive.
Hopefully we can have this view for a bit longer. You see stacked to the right side of the screen, the 3 lines. Those are the solar arrays. It's a 3-panel array. And once the guidance and navigation control system senses that it's got basically nulled the rates, the spacecraft is stable, it'll start to deploy those solar arrays. And it will be done autonomously. It's dark out there, so we're starting to lose our view. We are now passing the milestone in which we expect the solar arrays to be deployed. Again, this is the expected milestone. It's dark out there. Again, no sunlight. Now you're looking at a view of inside the Mission Directors Center. That front row there, staffed by the team from the Goddard Space Flight Center as they look anxiously at their monitors. The solar arrays are expected to take a few minutes to deploy. If it holds to the milestone, so we just got word that they have confirmation the solar array deploy has begun. Again, solar array deploy has begun for the spacecraft. It's a 3-panel array. It's a critical milestone. And what goes hand in hand with that, Mick, is for the GNC, the Guidance, Navigation, and Control, to get that spacecraft and that solar array sun pointing. Can't do it yet because there is no sun in its current state. But we got a good ride into space. We will continue to monitor the nets here and the PACE spacecraft team. But in the meantime, we're going to send it back to Jasmine and Laura.
Thank you so much, Daryl and Mick. A beautiful launch followed by a smooth ride into space so far for Pace. Laura, what do you think?
It was absolutely stunning, and we are so relieved. Everybody in the Pace team has been cheering. All of our NASA colleagues have been cheering, as have all of you been cheering. So it is a great dawn for Pace and ocean and atmospheric sciences.
It really is. That was a great way to put it, Laura. So if you are just joining us, you are watching NASA's official coverage of the Pace launch. That's the Plankton Aerosol Cloud Ocean Ecosystem. It lifted off about 16 minutes ago aboard a SpaceX Falcon 9 rocket from right here on Florida's Space Coast. So now Pace is on its way to orbit 420 miles above Earth. We're able to collect data on both particles in the ocean as well as the air. Let's take a closer look at how those are connected.
Between September 2019 and March 2020, wildfires killed billions of animals and decimated more than 200,000 square kilometers of Australian forest. Some thousands of kilometers away, in the Southern Ocean, massive algae blooms covered a surface larger than the area of Australia itself. Just how are these wildfires and ocean blooms connected? To untangle that, we look to the carbon cycle. The carbon cycle is the flow of carbon between reservoirs in the atmosphere, plants and animals, land and ocean. If we look to the ocean reservoir, carbon dioxide is also absorbed by phytoplankton, microscopic organisms that convert carbon dioxide, water, and sunlight into carbohydrates like sugar and oxygen through photosynthesis. Carbon dioxide released into the atmosphere eventually becomes available for aquatic photosynthesis. But photosynthesis also requires nutrients such as nitrogen, phosphorus, and iron. Without the right proportions of these nutrients, photosynthesis doesn't happen, which can be seen in the iron-limited parts of the ocean, such as far offshore of Australia. Atmospheric aerosols released by fires, however, contain carbon as well as other nutrients essential for plant growth, like iron. When these aerosols are deposited on the ocean's surface, these nutrients become available for photosynthesis. This iron from the Australian wildfires is now thought to have stimulated the massive Southern Ocean phytoplankton blooms of such magnitude that they converted an almost equivalent volume of carbon dioxide released by the fires into carbohydrates and cellular material.
With an instrument like OCI, where you're measuring this full spectrum of color, all the colors of the rainbow you can imagine, we can start teasing apart the species and the different functional groups and different communities that exist.
The data from Pace will help define those communities, allowing for clearer connections within the reservoirs of the carbon cycle. These fires emitted a huge amount of carbon and other aerosols into the atmosphere. Those aerosols contained essential nutrients that are thought to have stimulated the rapid growth of phytoplankton in the Southern Ocean. And these kinds of connections can have big impacts.
And it's really important to know where the carbon is going and where your food source is going. This is important for not just climate studies, but food security.
With data from Pace, we'll get a clearer picture of carbon as it links land use and fires, atmospheric aerosols and marine communities, and ultimately improves the data that we put into climate models.
NASA scientists are hard at work using data like what they'll get from Pace to better understand climate change. Megan Cruz is standing by with one of NASA's experts on climate science right now. Megan?
This is Kate Calvin. She's NASA's chief scientist and also the senior climate advisor for the agency. What a beautiful launch we just saw.
It was beautiful, and it's so exciting to see this mission go and start to send us data soon.
Yeah, so let's talk about that. Pace is going to advance our understanding of the Earth's climate and how it's changing so drastically, right?
Yeah, absolutely. So we're seeing, an increase in warming. The last 10 years have been the warmest since modern record keeping began, and that warming trend is driven by greenhouse gases, including carbon dioxide. And Pace is going to give us a better understanding of how the oceans absorb carbon and that exchange of carbon between the ocean and the atmosphere. It's also going to tell us a lot more about these tiny particles in the atmosphere called aerosols that can reflect or absorb sunlight and affect cloud formation, all of which is really important for climate.
So we're obviously going to learn a lot, but how can we use that data and turn it into how we address climate change?
So one of the important things, the more we understand about climate, the better we can predict it in the future. And we can take that and use that to help better plan. And that's something we're working on throughout NASA, is helping people understand understand what's happening where they live, what we know about what might happen in the future, and make sure they have that information ready at their fingertips. And PACE is going to help contribute to that.
And what I love about this is PACE is not the only Earth-observing satellite out there. And in particular, it's going to work with one that launched just last year, or a little bit over a year ago, that's really going to help us get a better understanding of our oceans.
Yeah, absolutely. So NASA has more than 24 satellites and instruments in orbit. They're each designed to measure something different. So we can see things like vegetation, carbon dioxide, clouds and precipitation, or oceans. And so you mentioned the satellite from about a little over a year ago called SWOT, or Surface, Water, and Ocean Topography. So what SWOT's looking at is the physics of the ocean. So how the water moves, the height of the seas, how it mixes. What PACE is going to do is tell us what's living in that water. And they're both really important because the oceans absorb a lot of heat and carbon, and understanding how the water moves and what's living in it will help us better understand that.
And really quick, what would you say to the team right now as they're about to embark on a wonderful opportunity to learn so much for the Earth?
Oh, this is just such an exciting time. It's such a great mission. It's taken a while to get here, but we've launched, and in no later than 60 days from now, we'll start to have data, and it's going to give us information not just about climate, but about air quality, water quality, fisheries, harmful algal blooms, and it's just really exciting to be here.
And that's data we're going to share with the public, so that's exciting as well.
Absolutely. All the data will be publicly available.
Great. Kate, thank you so much. I really appreciate your time.
Yeah, thank you.
All right, so you guys have been hearing Daryl and Mick talk about waiting for power positive, so let's turn it back to them so they could walk us through that next milestone.
All right, thank you very much, Megan. Back here at Hangar AE, we heard some brief applause when we had the spacecraft separate, but now comes the big moment, getting that confirmation that the solar arrays have deployed and they're catching sun. We got a little ways to get there.
Yeah, absolutely. The team was very happy to see deployment off a second stage, and I know that the next big milestone for them is that power positive. So.
All right, there you see a look inside the Mission Director's Center as the teams wait for that telemetry to come in from the PACE Observatory, which is flying free now. Launched into an orbital eclipse. And so once the solar arrays are presumably deployed and it comes out of the eclipse, the spacecraft will automatically orient itself towards the sun, and that's when the team will be able to see that power flowing through the solar panels at a rate that would tell them that it's sun pointing and it's in the right place.
Sun pointing and charging that battery back up. You know, they've been on internal power, using that battery power for flight, and so that solar panel will help them get the vehicle charged back up and continue their mission.
That's right, those batteries are Mick. And as it does, it goes in from the eclipse side, those batteries will power through the dark phase. And so charging those batteries are key to PACE carrying out its mission. If you're just joining us, we had a successful liftoff at 1:36 a.m. Eastern Time from Launch Complex 40 here at the Cape Canaveral Space Force Station. We rode the first stage of a Falcon 9 rocket for several minutes before it separated, came back down to LZ-1 after about 7 minutes. Stage 2 of the rocket then flew PACE for about 7.5 minutes, ultimately separating around 12.5 minutes after liftoff. And we watched as PACE went on its own into space and separated from that stage 2. It was in the midst of an eclipse, so it was a quick goodbye. We saw it go off into the darkness of space.
Yeah, I'll tell you, the stage 2 were incredible. Not only watching PACE separate from stage 2, but just continuing on its way to perform this exciting mission that we've heard all about this morning. But that video, just, it was exciting to watch that and be a part of this. And I know the PACE team is anxiously awaiting that power positive information. But, we got PACE where it needs to be and on its way. So this is a great start to the launch this morning.
Jim Free, NASA's Associate Administrator, is here on hand. He is there in the control room. You can see him in the second row in the middle, the fourth from the right. All along the first row, the teams from the Goddard Space Flight Center. They have a team back at Goddard that is online as well, the Mission Operations Center, and that's where the spacecraft will be commissioned. And it is also where they are sending commands and receiving telemetry at this very moment. I spoke to PACE Test Director Nusha Hagani, and she relayed to me that these are some tense moments. As a team watches and waits to get that confirmation that the sun is shining on the solar arrays and it's oriented in the correct direction. Once they get that confirmation, I'm sure we will see a reaction from the team. According to the milestones, we are at the point in which the Goddard spaceflight team can command the spacecraft. After waiting for a period of time as it came off of the second stage. That's so they don't get anything mixed up with the second stage of the rocket as it's going into a disposal burn and the spacecraft is going on into its orbit. T plus 29 minutes and counting. We are now into the moment where we would expect the milestone of power positive to happen, but we also know and have been told by the Goddard team that it could take a little longer.
Yeah, Daryl, I know as the spacecraft team is waiting for this information, the launch vehicle team has been doing a quick look on how Stage 1 and Stage 2 performed today, and so far everything is reporting in as perfectly performed launch vehicle today. As we saw in the video spacecraft step, Falcon 9 delivered pace where it needed to be. So that's good news on the quick look of the launch vehicle. And I know that the PACE team is excited to be where they are, just waiting for that power positive confirmation.
Great report out there, Mick. And as PACE was delivered to an orbit 674 kilometers, about 400 miles above the Earth. PACE has 10 years of fuel on board to do its observations and report back its scientific data. But you never know with these satellites, they can go a lot longer. Just depends on how they use their fuel in the course of the next 10 years. Scientists, of course, always want more data, and many times they're rewarded with that when a spacecraft exceeds expectations, as often they do. Again, if you're just joining us, we are awaiting confirmation of a milestone called power positive. That milestone means that the PACE spacecraft has oriented itself into the sun and deployed its solar arrays fully so that it's getting power on all three panels so that it can charge its batteries and begin turning on the scientific instruments. T plus 32 minutes and counting. PACE spacecraft dimensions are 3 meters by 3.5 meters. It weighs 1,439 kilograms. Has a 3-panel canted solar array. The critical final milestone that will allow the team to take a deep breath and, of course, continue to monitor the telemetry trend and all right, you can see the applause there in the Mission Director Center. The spacecraft team happy to report that they have power positive on the PACE spacecraft. Again, the final milestone, power positive on the solar arrays on the PACE spacecraft. That's great news. Congratulations to the PACE team.
Absolutely.
This is a big moment.
Successful mission. There we go. Excellent news. Spacecraft's happy. We saw some clapping. Things are going great. PACE is on its way. Power positive. That is a successful mission for PACE.
And just to recap, we launched at 1:33 and 36 seconds a.m. Eastern Time from the Space Coast here, Space Launch Complex 40. We rode the Falcon 9 for about 7.5 minutes and then got into space. We watched PACE separate about 12 minutes after that, Mick. And then at T plus 33 minutes roughly, we got confirmation that not only the solar arrays had deployed, but also PACE had aimed itself towards the sun once the spacecraft came out of a orbital eclipse, which was a big moment.
Very, and not only get launch vehicle perform the way it did, bring the booster back to landing zone 1. Daryl, I've told you this many times before, but this never gets old for me. I love this, and I'm just so excited for not only the launch vehicle team, but for the PACE spacecraft team. Very excited to see them on their way and get ready for this exciting mission.
A job well done by all today, and certainly now the PACE team can rest easy, but they're still working. The power team is going to stay on for another couple of orbits, which is another 3 hours, to make sure that they see that power data is trending in the right direction. And of course, commissioning of the PACE satellite will take another 60 days before they can start getting in some of that scientific data. this launch, of course, the first launch for NASA's Launch Services Program, but it is, as I understand, the last launch for a very special member of your team.
Yeah, absolutely, Daryl. It's the first for 2024, but this is the last launch for our program manager, Amanda Mickiewicz. This marks an end of an era. It's a conclusion of a remarkable journey. Amanda, I just want to say you're amazing. Your leadership transcends the boundaries of the Launch Services Program and the Kennedy Space Center, resonating across the entire aerospace community. Even with your extraordinary achievements, you remain remarkably humble in your role. You always challenge us to strive for success. Over the past 14 years, you have steered the Launch Services Program with unwavering dedication, maximizing mission success and contributing significantly to the evolution of the space industry. Your mentorship, your friendship, and your compassionate leadership style have been the driving force behind our team's pursuit of excellence. It is no surprise that you stand as a DBUS Award winner, and your absence will be deeply felt. As your LSP family, we gather this morning on this, your final mission, to say, see you later. While we will miss you dearly, we hope you realize the profound impact you've had on each of us, the collective achievements, the shared memories, and the spirit of excellence you instilled within us are the testament to your remarkable leadership. As you embark on this new chapter of your life, know that your influence extends far beyond the boundaries of the launch pad. You are not just retiring, you're passing the torch to the next generation of dreamers, innovators, and explorers. The legacy you leave behind is not merely in the missions accomplished, but in the lives you have touched and the inspiration you've ignited. Godspeed, Amanda, and thank you for this extraordinary journey.
Great words there, Mick, and certainly well-deserved. Amanda Mickiewicz, DBUS Award winner.
Yes.
One of the highest honors here at NASA. So from all of us at NASA, we wish Amanda well in her retirement. Well, that's going to do it for us here at Hangar AE, a successful launch of the PACE spacecraft and solar array deployment. Great success by all involved today. And now we'll send it back to Jasmine and Laura to wrap up the show.
Go PACE.
All right, go PACE for sure. Thank you so much for taking us all the way through solar array deployment, Mick and Daryl. So now we are back with yet another member of the Launch Services team, Denton Gibson. You are the Assistant Launch Manager from LSP. Thanks so much for being here.
Thank you for having me.
Of course, we're happy to have you. So today, this was your first launch in your new role as, Assistant or Backup Launch Director. How did things go from your perspective?
Oh, the launch went well. This is one of the cleanest launch counts that I've seen. The launch vehicle performed phenomenally. And we separated the spacecraft on time as predicted, and as you just saw, we got power positive, so the mission went flawless.
Great.
And that makes me very happy, of course. But tell us, what other launches does LSP have planned for this year?
So the other things we have planned for this year is the GOES-U, which will be coming up towards the end of April, and that'll be on a Falcon Heavy. And later on this year, we have Europa Clipper, which we're going to one of the moons of Jupiter, which will also be another Falcon Heavy. So we have 2 Falcon Heavies lined up this year.
Great. So a lot of nice things to see from LSP this year. We did just also see that beautiful tribute to Program Manager Amanda Mickiewicz. So, Denton, is there anything you want to say to Amanda and the rest of the team that worked on PACE?
Yes. Oh, first of all, I want to say, thank you to the SpaceX for giving us an excellent ride to space, and all the hard work and dedication that went into this from the LSP team as well as the Goddard teams. Did an amazing job to make sure that this mission was successful. And also our colleagues at the Space Force who, helped us out when we had some challenges with weather early on. They gave us a lot of good support from that, and helped us out on day of launch. And to Amanda, I would like to say, you will be missed. She's been a very good mentor to a lot of us and to me personally, and she's been an amazing leader for the Launch Services Program. So thank you to the combined LSP, Goddard, SpaceX, Space Force team, and I know everybody will miss Amanda.
For sure. It really is a collaborative effort between all of you. Very well said, Denton. Thank you so much. And it was a beautiful, like you said, almost flawless launch campaign today. So great job for the LSP team. And for our viewers, if you missed that launch earlier in this morning, you are welcome to watch that again. We actually have a replay for you right now.
Minus 10,
9, 8, 7, 6, 5, 4, 3, 2, 1. booster ignition. Full power engines. 9 and pace, helping keep pace with our ever-changing ocean and atmosphere.
Stage 1 propulsion is nominal.
All 9 Merlin engines lit up and roaring. 1.7 million pounds of thrust.
Chamber pressures on the telemetry and everything look good here, Daryl. 9 engines performing very well.
That's great news.
Power and telemetry nominal.
Steep climb into its orbit. We ride about 2 minutes on the first stage. A view from the rocket camera.
Vehicle supersonic.
Here we hear Falcon 9 supersonic coming up on max Q, maximum dynamic pressure on the launch vehicle.
Max Q.
Pass through max Q. The vehicle continues to perform nominally, all 9 engines.
Now that PACE is on its way, let's take one final look at this mission with some social questions for our ocean expert, Laura Lorenzoni. Thank you again to those of you that have been sending those in. So our first question comes from Huge XO on X. They ask, what is NASA going to do with the information gathered by PACE?
Great question. And NASA receives the data, and it is our job to distribute those data and make it freely available. NASA has a very robust open science policy, meaning that we want to make sure that everything that we collect through our satellites or our field campaigns is open and available to the public. And so we're going to have first light for PACE in the middle of March, and this means that this is when the data is going to be available. But truly, PACE and PACE's data is meant to help the public, to help anyone, any citizen, decision makers alike make really smart decisions about anything that is important to them.
Right. It is nice to see that the data from PACE really is going to help the public. So our next question comes from Mondo305 on X. They ask, how will these studies help with coral reefs?
And that is an excellent question. The data from PACE, as we've been talking about, it really, one of the biggest instrument is the ocean color instrument. That tells you, what color is the ocean. And we've talked about phytoplankton. We haven't talked so much about sediment or about other things that are suspended in the ocean. And so coral reefs really depend on clear water. And understanding what kind of variations we have with respect to water quality or that color of the water is going to be really important for us to understand what conditions are really impacting negatively coral reefs and which ones are actually benefiting reefs.
Great. Thank you so much, Laura. We do have one final question. It comes from Mango Ali Ellie on Twitch. And they ask, how long is this mission and how long before the results are shared?
That is also an excellent question. PACE's original mission is 3 years. That is primary mission. However, as you heard through the broadcast, PACE has 10 years of fuel, which hopefully means that PACE is going to have a really long life. And NASA does have a lot of success with its missions, and they go into extended operations and last for a really long time, which is, it's absolutely fundamental, as we've talked about, to really understand that climate trend and that climate record. And you can expect PACE data hitting our data repositories and being available to all of you by mid-March.
Okay, great. You heard it here. Mid-March is when we are going to be looking for that PACE data. We also have a QR code here to give you so that way you can look for where you can find that information from PACE. So thank you so much, Laura, for answering those questions. And thank you to the public for sending them in using hashtag AskNASA. We really appreciate that. So that's going to wrap up our coverage for the launch of PACE. I want to personally thank you, Laura, for being here, our ocean expert, to answer all of our questions. It's been a pleasure having you.
Jasmine, you've made this absolutely wonderful. So thank you so much. And thanks to all of you that tuned in. It has been a real privilege to be able to share this historic moment with you. And we really are standing in the shoulder of giants. If it wasn't because of the legacy that we've had on Ocean Color and all the people that have worked generation after generation on these kinds of technology, of instruments, we wouldn't be here. So thank you to all of you that have made PACE possible, and go PACE.
Yes, go PACE. It really is a collaborative effort. Thank you so much to all the teams that came together for this. You can follow PACE online at nasa.gov/PACE and by using hashtag #KeepingPace across social media. Thank you again so much for joining us. And until next time, go NASA, go SpaceX, and go PACE.